Hello and welcome to the complete course of Azure Machine Learning. So in the last lecture, we have created an environment of PyTorch, and in this session, we'll learn how to write a PyTorch code, and how to execute in a virtual environment. And in the next lecture, we'll see how do we execute the same code into an Azure Machine Learning Studio. So let's get started. So here we need to import few of the libraries like torch libraries, torch util data, and the torch.nn, right? Along with the numpy and pandas. So first of all, what we're going to do it, we'll first try to create a data frame from this CSV dataset, right? So we have created by using data equal to pd.read CSV. Once that is done, we will create a feature, and the feature would be the all the features excluding the last column. And similarly, my ystr is a label or a target variable which contains the 0 or 1, the binary classification, and that's how we will segregate it. And here, what are we doing it? Because this feature would be having a positive and negative numbers over there. So we'll see if it is positive, then it would be considered as 1, or else it would be considered as 0, right? So once that is done, we'll convert this feature list into a tensor. So how do we convert it into a tensor? So why are we converting everything into a tensor? Why not the numpy array is sufficient? See, whenever we are executing a deep learning, the deep learning solution is meant to execute the large dimensional data set like images, videos, and all, right? Now, because the tensor is having a capability to get executed into a GPU, my NumPy array will not have that capability to execute it into GPU. That's the reason we would create our data set into a tensor so that it can execute in CPU as well as in GPU, right? So now we'll first convert my data set or a features into a torch tensor, and once it will be done, the same thing needs to be done for the label data set, that is the Y, right? Once that is done, we would be creating a data set. So see, here we are creating a class of a data set, and here we are initializing the x tensor and the y tensor, right? And once that has been initialized, we'll be passing the few inbuilt function which, like the get item, will pass the index of an x and the index of y. However, my len function will send the length of, or the shape. Here we are saying the length of the x. Length of x means how many rows that particular data set has, right? Now, when we'll call this data set, this contains an object of this data set, right? And now we would be executing my data set into a batch, right? Because either it would be a batch format or stochastic format, right? So in this, what we are doing it, we are creating a mini batch of 32. Here we are mentioning the 32 size. We are passing in data loader. What data loader does is data loader creates my data set into a mini batches, right? So once this train load does that, create a mini batch, we need to pass a certain parameters. So this the parameter says that my header layer 1 would be having a shape of the number of a features it has, and then based on that, it you can give the number of layers in a second layer, then a third layer, the number of neurons it contain, and finally, because it is a classification problem, the output layer would be 1. So that neuron would contain either 1 or 0, right? Now create a model. So once the model is, you are creating a class model having a module name nn.module, and you need to initialize all this hidden layer which you can pass it to the runtime. So you are passing the hidden layer 1, hidden layer 2, at 3, and the output layer, right? So here what you are going to do it, you are creating a layer, self.layer equals to nn.linear, hidden layer 1 and the hidden layer 2, and Similarly, for the hidden layer 2, this hidden layer 2, the output of a layer 1 would become the input of a layer 2, and similarly, the output of a layer 2 would become the input of a layer 3, right? And finally, the output comes into the output layer. And the sigmoid, you are just passing the activation function as a sigmoid and the ReLU function, and once that is done, you are creating the forward propagation. The forward propagation says that once the output layer, layer 1, has been created, the activation function you are passing as ReLU. Similarly, once the output of the layer 1 goes into the layer 2, it would be passed to the ReLU functions, right? And finally, the output layer, the final layer that we call as an output layer would be passed to the sigmoidal function because the value would be lying between 0 to 1. Once that is done, you would just call this particular model. You have to create a cost function, that is BC loss over here, and then finally you will do the using the optimization function as an atom. So once that is done, you are creating an epoch of 10, and once the epoch has been created, uh, you have this input label, input value, and the output value, that is the label, and then you will pass it into this particular model. And once the model, you have passed the mini batch size. So here you have seen the mini batch size is 32. So the 32 rows of that batch would come and feed it. It will do the forward propagations, pass through the multiple activation function, calculate the cost function, and then once it will calculate the cost function, it will optimize it. It will create a gradient descent and then do the backward propagation. So this would into a one layer, and then again the next batch would come. It will optimize the gradient descent and then finally comes up with the best optimal accuracy. Right. So once that is done, this piece of a code will calculate an accuracy, right? So this is the short notes of how do we write a code in a PyTorch. However, if you want to go into a details, then you can go through my other deep learning solution videos wherein it all the details would be explained it in details, right? So that is how we are creating a deep learning model in PyTorch. And in the next lecture, we will see how to execute it into a local environment. Thank you.